Okay, so here are here's me going through the proofs a little more slowly than I did in class, the four you struggled with in class, and you having a chance to correct yours and redo them and give me correct answers and tell me what's wrong with it. So first of all, one of the big things in class was that a lot of you guys, I don't want to sound critical, but I'm going to have to be, I don't think paid attention to the first statement at all. Because it says segment CE bisects angle BED. We bisected an angle. That has nothing to do with side BD at all. Okay, so what that means for us then is we have a pair of congruent angles here at BEC and a DEC. Okay, so we have a pair of congruent angles. Now, we also have, and they didn't draw both of them in there, so I think some of you guys weren't paying attention closely to that either. We also have our second piece of information is that angle BCE, excuse me, and ECD are right angles. Now, there are a lot of places you can go with that, but the way this is primarily focusing is the fact that, hey, if you have right angles, you have a pair of, excuse me, hiccups, you have a pair of congruent angles. So we have a pair of congruent angles here at BEC and DEC. We have a pair of congruent angles at BCE and DCE. So we have two pairs of congruent angles. So it means we can either use angle, angle, side, or angle, side, angle. So the question is, where is our pair of congruent sides coming from? And again, what a lot of you thought was, you thought, oh, the congruent sides are BC and CD because it looks like it's in the middle. It looks like it, but notice there's nothing up here about bisecting a side or a segment or anything about a midpoint. You have to have those two things for congruent sides. So our pair of congruent sides must come from somewhere else. And a lot of you caught it, you just didn't use it properly. Reflexive property right there. Okay, so now it's time to put the proof together. Okay, to write out the reasons, statements, and reasons. So first of all, statement, reasons. So segment CE bisects angle BED. Sorry, I know it's slobby, but I don't have a ton of space in here, and these guys have fat tips on them. And then angle BCE and angle ECD are right angles. So we have identified the given. Now sorry, I should have mentioned this. We have two angles and a side, and that side's between the two angles, so it's an angle, side, angle proof. Angle, side, angle. So first thing is one of our pairs of angles. I'm going to do BEC first. That one came from the bisector. So that's just definition of bisector. Okay. Number 3 then, the other pair of, we'll do the sides. So we can do angle, side, angle. That's CE is congruent to CE. And that is by reflexive property. Okay. And then number 4, that is, and this is the one that, again, a lot of people missed. We have angle, side, angle, but if we look at our statements, we've only proved a pair of angles and a pair of sides congruent. We have to prove that the pair of angles are congruent. So you have to explicitly state that angle BCE is congruent to angle DCE. And the reason was all right angles are congruent. And then number 5, now we've done angle, side, angle. We've got it proved in the problem. Triangle ECB is congruent to triangle ECD by angle, side, angle. Okay. Now, I'm talking. Okay, I'm just talking you through it. I'm taking my time. But here's the thing about this problem. If I look at the counter right now, I'm at 4 minutes and 20 seconds, around that. You can't assume that you're going to get these problems done in a minute. You may have to take a little bit more time to write out all your reasons, to write all your things. And I knew exactly where I was going with it too. So it might take you a little bit of time to look at a problem. These don't come instantly. So you've got to give yourself the time to do that. Okay. Now, number 7. 7's a good one because 7 has multiple ways to get through it. You could actually do an angle, side, angle proof or a side, angle, side. Now, some of you got stuck because you didn't look at the given at all. You looked right at the drawing and you saw, oh, I have a pair of congruent sides. I have a pair of congruent angles at W and Y. So XZ, oh, reflexive, good for me, I caught reflexive, and you stopped and said, well, wait a second, this becomes side-side angle or angle side-side, whatever. But you didn't look at the given. Yes, we have a pair of congruent angles. Yes, we have a pair of congruent sides. But look at this statement right below it again. We also have XZ bisecting angle WZY. If it's bisecting it, that means it's cutting it in half and giving you two congruent angles. So we also have another pair of congruent angles in this problem. And since it's XZ bisecting WZY, the angles that are congruent are these angles here. Okay. So now this is where again you could take this as side angle side or angle side angle. It just depends upon which way you're going with it. But again, if all you're going to do is look at the drawing and make markings on the drawings, you're never going to succeed at these because you need to use the given as well. You need to go back and look at that information. Okay, so let's say we'll do the angle side angle proof first. Because I believe I haven't looked at the answer key for the book, but I believe that's probably what they're intending. Otherwise, they wouldn't have given you W and Y congruent to begin with. They just would have skipped those and said angle bisector and side WZ is congruent to YZ. So first of all, given angle W is congruent to angle Y, WZ is congruent to YZ, and XZ bisects angle WZY. Given. Okay. Now, next, we got to use some of this stuff. So, if we're going to do the angle side angle proof, we've already got the two sides or got the pair of sides and a pair of angles. We need another pair of angles. So that's where the pair of angles of angle WZX is congruent to angle YZX. And that reason is bisector. So definition of bisector. Or definition of bisect. Some of you guys said that's fine. But I don't know, old habits of bisector. So now again, we had to start off with, I'm going to use a different color to kind of highlight this. We had our pair of angles up here, we had a pair of sides here, we had our other pair of angles here. So we have angle, side, angle. So now step 3, we're done. Step 3, we're done. 3, triangle XWZ is congruent to triangle XYZ, Y, angle, side, angle. Okay. Now alternatively, you could have also proved it using side angle side. So I'm hoping this stays in frame enough, but I'm just going to have to kind of bounce back and forth. Statements, reasons. 1, we don't need W is congruent to Y, so I'm not even going to bother writing it. I'm going to write WZ is congruent to YZ, and that XZ bisects angle WZY. Okay, that's a given. 2, again, I've got my pair of sides, I need my pair of angles, so I'm going to jump to the angles. Angle WZX is congruent to angle YZX by definition of bisector. Now, if I want to be really picky, we should technically say angle bisector because it is an angle bisector. It's bisecting an angle, but it does the same process. So we already got a pair of angles, or sorry, we got a pair of sides up here, got our pair of angles here. Now we need our third pair of sides, which again, a lot of you caught from the drawing, and that's tremendous. I mean, I hope that comes off that I'm legitimately excited we see reflexive property everywhere we see it. But you've got to also use that angle bisector, otherwise it doesn't need to be in the given. So that's reflexive. And then step 4, oops, sorry, I'm running out of space there, aren't I? Reflexive. Triangle XWZ is congruent to triangle XYZ. Side angle side. Okay, so that proof could go 2 different ways. 7 could. It could either go an angle side angle proof, which is a little shorter actually, or a side angle side proof. And again, looking at time, I just did 3 of those in like a little under 10 minutes. So they do take some time. Number 9, one thing I will say we did a really good job of as a class collectively is this first piece of information that V is the midpoint of YW. Here's YW, so a lot of you knew midpoint theorem that VY and VW were going to be congruent. However, you got to make sure you pay attention to that statement closely because it only says YW. It does not say that V is the midpoint of anything else. And some of you just assumed, oh, well, it must be the midpoint of X of ux as well, or you're just maybe grasping at straws. But there's nothing in there talking about the fact that ux has a midpoint as well, so we can't assume that those segments are congruent too. Now after this, there's your pair of sides, and we're going to use an angle side or angle side angle proof for this problem. And really it comes down to what angle pairs did you decide to come up with or use in the problem as to which one it is. So first of all, a lot of you caught the vertical angles in the drawing, and that's great. Hopefully, you know, those are stepping up. Those jump out at you pretty good. We got a pair of vertical angles here, here, and here. Okay, so that's a pair of angles. Now we need two pairs of angles, and the other two we actually can get from anywhere because they're parallel sides over here. So if I just make a SketchUp over here real quick, I could think of here's uy, here's wx. I could think of YW as the transversal, meaning these two angles are congruent. Or I could think of UX as the transversal, meaning those two angles are congruent. And I also could have even avoided the completely avoided the alternate interior or the vertical angles as well, and just worked with you know, the two pairs of alternate interior angles that are going to be congruent, Y and U, or Y and W, and U and X. So we have here, this is Y, this is W, here's U, here's X. So I could have gone a couple different ways with this as well. So that's another thing for this problem. But depending upon which way you go, you have a whole mess of ways to prove this. So I'm just going to label all of these here. So you could do, if you used, well, first of all, let's just say we use the vertical angles, because I think that's something we're more comfortable with. So we do our statements and reasons. 1, V is midpoint of YW, and UY is congruent, or sorry, it's not congruent, it's parallel to XW. Okay. Oh, and I didn't say this, and I should have. Don't forget, anytime you see parallel lines, okay, anytime you see parallel lines, that means you're going to have a pair of congruent angles somewhere in the drawing. At least one pair, if not two. So again, you know, those things to memorize: parallel lines is congruent angles. Okay, parallel lines means congruent angles. So we got one, that's given. And again, I apologize for the sloppiness. I need to get new markers. The ends of these are all getting dull, so it's starting to kind of smudge. 2, okay, I'm going to use the midpoint. It's going to jump with that to begin with because that's the first statement. So I know that YV is congruent to, it doesn't matter if you say WV or VW because it's just a segment, so we're not going to be that picky on that. We just be picky about the fact when we do the congruent statement. But it technically would be, if I'm going to do YV, it'd be WV. And that is the midpoint theorem. Okay. Now, number 3. Okay, part 3. I've got a pair of sides in this problem. Now I need to bring up a pair of angles. That's my next step, is to bring out a pair of angles. Again, it's up to you as to which choice you're going to use. Let's just say, for the sake of argument, we're going to use the vertical angles for both proofs because we're going to look at both of these. So I'm going to say angle UVY congruent to angle XVW. And that's vertical angles theorem. Okay. And then 4, now we got that knocked out, we got to use one of the pairs of alternate interior angles. Now I'm going to use Y and W for the first one. Angle Y is congruent to angle W. And I could use the single letter name because there's no other angle Y, there's no other angle W. And that is the alternate interior angles theorem. Okay, and hopefully you can read my chicken scratches. But we have that. Now if I do that, I get angle and angle. So I have, this would be side angle angle, but we don't have a side angle angle. What we have is an angle side angle, or angle angle side. So we have to look at this. What do we have? Well, I have in the drawing, I'll copy it down to black again for this one. Okay. I have those two segments congruent. I have these two angles congruent, and I use these two angles. So in this case here, I've got angle, side, angle. So step 5, triangle UVY is congruent to triangle XVW by angle, side, angle. Now, I'm going to cut off, I'm going to cut it off here. That's the first way to do it. The second way, if I do a different one for angle 3, if I do instead of y and w, if I do u and x, let's say. So, same proof, it's just step 4 now. I do angle u is congruent to angle x. Now, it's the same reason. It's still alternate interior angles for u and x. Alternate interior angles theorem. Okay. Now if I do a drawing of the triangle the way I've got it, the two triangles set up, you've got y, u, v, w, x. Okay. We know, again, these two sides are congruent. We know these two angles are congruent because those are we use the vertical angles. But instead of us saying y and w, we're going to say now u and x. Well, now that's no longer side angle side, or that's no longer angle side angle like this one was, where it was angle side angle. Now we're talking angle angle side because we have the opposite side and angle pair. Okay. So so still same triangle UVY. Gosh, this isn't fitting. Triangle UVY is congruent to triangle XVW by angle side. Okay. So again, those are the two different ways you could have done 9. Or two of the different ways you could have done 9. Now number 10. Number 10 is the same thing. You could do this one a couple different ways. There's a quicker way, I think, and a longer way, but it doesn't really matter. The key is, again, you have a pair of congruent sides, already marked those. You have a pair of parallel sides. So again, the first thing you should be thinking as soon as you see this for a test or homework or whatever, or in a class problem, is, parallel lines. Right there. We've got to have some congruent angles. Okay. Now, what a lot of you caught, just like the last one, is you caught the vertical angles. Great. Okay, so we got the vertical angles. So now what we have is we have a pair of angles and sides that are opposite each other. So this is looking like it's going to be an angle side angle theorem, or angle angle side, excuse me, angle side, and that's true. Okay. The real question is just what pair of angles do you want to use? Do you want to use angle M and angle R? Because I have a Z shape this way and a Z shape this way. If I do M and R, I'm using the backward Z. If I do S and Q, I'm using the forward Z. Sorry, S and Q. Yeah. So when I do that, depending upon which pair of angles I use, I get a different angle side. So statements and reasons. 1, MS is congruent to RQ, and MS is parallel to RQ. 2, the vertical angles. Angle MPS is congruent to angle RPQ. That's vertical angles theorem. Now, I'm going to call step 3, I'm just going to call it two different step 3s. The first step 3 is angle S is congruent to angle Q. The other step 3, now let's do that in a different color. Let's do that in red. I haven't used red yet here. Let's do this. The other step 3 is going to be that angle M is congruent to angle R. Doesn't matter, because both step 3s are alternate interior angles. So it's the alternate interior angles theorem. And then for step 4, the two triangles are now congruent. Sorry, just a second. Yeah, so triangle MSP is congruent to triangle RQP by angle side. Okay. So this clocked in at just 20 minutes. Okay, hope there's plenty of time for you to stop and pause. But if you got stuck on a step or something weird, shoot me an email. Or come in Monday morning. If your bus gets in even at 7:20, it might just take us 3 minutes to look over one of your problems. But again, that's me walking through every single problem you had. So your homework along with this is to look at the problems I gave you. And I know, I apologize, I put marks here and there, I made little notes, and I just decided about halfway through to stop doing that. But your homework is for you to correct yours, write down the right answers, and explain what didn't work. And if you don't know, just say, I didn't know what I was doing, and I just wrote down anything I could think of. But hopefully now, kind of going through it, looking at your problems, you get a little bit of an idea of what to do to fix it. So I'll see you in class on Monday. Have a good weekend.